In this lesson, we're going to go over equations of circles, and this will kind of wrap up our circle unit. The general equation of a circle is this setup right here. Now, if you remember anything from the quadratics unit, we had something like this as our vertex form. Well, this is similar in the fact that this is moving left and right. It's my horizontal shift. Same thing. This is still a vertical shift, moving up and down. It's just opposite sign because now there's a minus sign here, just like there is here. And then this one is actually going to be the radius of the circle. And this comes from the fact that we have the Pythagorean theorem. So we're going to look at this circle right here and just generalize. So HK is going to be the center of my circle. So I'm pretending like instead of being exactly on the origin, it's moved to this point right here. So this piece is the radius. It's also the hypotenuse of the right triangle, because this is a right triangle. So the hypotenuse is represented in this case with r. So that's the c squared. We'll come back to that one in a second. Okay, and then I also have this side right here. Well, if I look just in an x direction, in a horizontal direction, to find that distance, I take my x and subtract h. Just like if I'm on a number line and I want to find the distance between these, so we'll say this is 1, 2, 3, 4. If I want the distance here, I do 4 minus 1 gives me 3. I go 1, 2, 3 steps. So it's the same concept, just with variables. And then similarly, we're going to do that same thing with the y direction. So in this one, it's going to be y minus k. So then I'm just going to set up the Pythagorean theorem, which states side squared plus side squared equals the hypotenuse squared. And there you have the equation of a circle. Now, one thing to keep in mind is with this equation of the circle, your radius is the r value. So what you're going to have to do is take this value and take the square root of it to get r. You also have the center of the circle right here. In the formula, that's our HK. So the center is H, that's an H, and HK. Okay, so we'll look at an example. So we have this first one. Make sure you guys can see that. We're just going to fill out the information for the center of the circle. So just like I was saying, this is your h value when there's a subtraction here. So the center is going to be 2. And then this is not my k value because there's not a subtraction there. So what I do is I rewrite it as subtract -5. Or you can just remember to flip the sign. So that -5 is the k value. So the signs end up flipping. So that's the center of the circle. And then to get the radius, that's where we look at this piece. Now, the radius isn't 100. We have to take the square root of 100. That gives me 10. So the radius is 10. So if I were to kind of trace out this circle on XY plane, and we will get into this a little bit more in a second. That's just going to move the center right 2 and down 5. Okay, and then it's going to have a radius of 10. So I would have a distance, that was a really bad circle, of 10 on that direction. So that's kind of what the circle would look like. Okay, let's look at the center and the radius in this next one. And then our last one as well. So I have that the center well, it's HK, and the H value in this case is 8 because I want minus my number. Now the K value in this case is, oops, you can't see that, 0 because you're not moving at all. There's nothing there. And then for the radius, that's where you take the square root of that value and you get 5. So this circle has a center of 0 or 8, 0 and the radius of 5. And then let's look at this last one. So again, we have to remember I want this to be a negative, so I want minus something. So that value is -3. And then I have a 1 because there's already a minus there. Now in this case, when you take the square root of 14, that's a number. That's my radius. But we can kind of see where that would be. So it has a radius of a little bit more than 3.5. So almost 3 1/4. That might be good to know. And that makes sense because if I thought about square roots that I do know, I know the square root of 9 is 3, and the square root of 16 is 4, and 14 is between 9 and 16, a little bit closer to 16, so it's closer to 4 than it is to 3. Okay, so I'm actually going to go out of order of my typical notes on this one, and what I'm going to do is we're going to look at graphing them, and then we'll come back to identifying center and radius because I want to talk about what that actually means. So we're going to graph these. So I need to know the center and the radius on both. So remember the center is at HK, where we're flipping the sign. And then the radius is the square root of that number. Oops, you can't see it. Square root of 9. So the radius is 3. Now this is what it means. So if the center is at negative 4, 2, it's that point of negative 1, 2, 3, negative 4, 2. 1, 2. Okay, and then it has a radius of 3. So I'm going to stay on my lines and go, this is a distance of 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Keep in mind that this is a distance of 1. This is a distance of 1. Going across is not a distance of 1. So I don't ever want to go diagonal. I want to just stay on my lines. And then I connect the dots on the outside. Now, for the first little while, your circles might end up looking like sideways squares, but just try your best. Especially if you have those points listed, then we know what you're talking about. We know what you were trying to draw. So that's our circle. So if I look at the center on this next one, I get 2, 3. So I'm going to go ahead and graph that point. So the center on this one is 2, 3. And then the radius, we take the square root of 16, and that gets 4. So I go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This one's a little bit bigger. And then we try to draw a circle the best we can. So something like that. And that's how you graph circles. So now we'll kind of pick back up with the rest of kind of laying it out. So we're going to talk about writing equations for circles. And it's going to be that same kind of, it is going to be that same equation where you have x minus some number squared plus y minus some number squared equals your radius squared. Okay, so when we fill this out, that's a good place to start. And then I can just input the h, k, and the radius. So this is your h value. So that's what goes here. This is your k value. So this goes here. Now I am going to be subtracting a negative, so I'm going to deal with that in a minute. And then this is your radius. That goes there. And then we're going to kind of clean this up. So I'm not going to do anything here. I just have x minus 5 squared plus. Now when I'm subtracting a negative, I'm really adding. And then I know what 1 squared is. It's just 1. So that's the equation of the circle. And then I could even graph this. So 1, 2, 3, 4, right 5, and down 2, 5, down 2, 1, 2. And then it has a radius of 1. So keep in mind that I'm not drawing to scale here, but that's essentially what it's going to look like. Okay, let's do it again. And I'm also going to write this one in the black, so I can put the black marker down. Okay, so in this one, this is my h value. This is my k value. And this is the radius. And then when I clean that up, I get x plus 3 squared. Now, if I take y minus 0, that doesn't actually change anything. And then 6 squared is just 36. And then this last one, go ahead and pause the video and try it on your own. Did you try it? Or are you just waiting for me to do it? Really pause it and try it on your own. That's how you learn. Okay, I'm trusting you. This is your h. This is k. And this is r. So I have x minus 1 squared plus y plus 8 squared equals 25. If you got that one wrong, maybe go back and look at what we did up here. Okay, now we're going to do some challenging problems. Not challenging as in too hard, but just something that's going to make us think about what's actually going on. So we're going to write equations of the circles again, but now I'm not giving you straightforward information. I'm not saying this is the center, this is the radius. I'm giving you other pieces of information. So in this one, it's giving us the ends of the diameter. So I'm going to, not to scale, just kind of draw this. So 0, negative 15 is going to be somewhere down here. And negative 2, 13 is going to be somewhere up here. So I have this circle where those are the endpoints. And I'm going to want the radius of the circle and the center. Well, the center is going to be halfway between the diameter, the ends of the diameter. So I'm going to take halfway between 0 and negative 2. So if I look at that, if this is negative 2 and this is 0, halfway between that is going to be 1, or negative 1. You can also add them together and divide by 2, because that's taking halfway between them. So I can either count to figure out halfway between my y values up here and down here, or I can add them together and divide by 2. And that gives me negative 2 over 2, which again is negative 1. So my picture is actually not correct because the center is going to be at negative 1, negative 1. So right here. Again, not drawn to scale. Okay, then I can find the radius by figuring out the distance. Now, the distance formula is good to know, but you can also figure it out by drawing a right triangle with it. So I'm going to find the distance for the x values, the distance for the y values, and then doing Pythagorean theorem to find the hypotenuse, or in this case, the radius. This is also, I was going to mention this, to find the center, is just the midpoint formula. So go ahead and look that up if you want to. So the x from the center to this point up here, and that was our negative 2, 13. So if the center is at negative 1, and I need to go to negative 2, I'm going back 1. If the y value is at 13, and I need to get to -1. That distance is going to be 14. I'm essentially subtracting that. And this negative, well, we did go backwards if we're starting here. If we're starting here, technically we went forward. So the negative will kind of factor out anyways. Okay, so the radius is going to, well, the radius squared is going to be -1 squared plus 14 squared. Because that's the Pythagorean theorem. Side squared plus side squared equals hypotenuse squared. So let's see. I'm going to have -1 squared plus 14 squared. And let's see if that's anything nice. It is not, so let's see if we can simplify it. So r is square root of 197. Let's divide it by, well, it's not even, so let's try dividing it by 3. Nope. Let's try dividing it by 5. Nope. Let's try dividing it by, well, it obviously isn't divisible by 5. 7. Nope. So if it's not divisible by 3, it's not divisible by 9. I could do 11. I could do 13. And then see how these numbers are getting closer and closer? I'm kind of out of options now. So that's actually going to be the r value. That's going to be the radius of the circle, which is a weird number, but that's okay. We actually found that it was, what's it? About a little bit over 14. Okay, so now what we're going to do is take this information and write an equation for it. Oops, that's a y. So that x value was -1, so we're subtracting -1. And we're subtracting -1. And now we're going to square this, so we can actually ignore it and just look back up here. So what is that squared? 197. So then it doesn't even matter that we couldn't simplify it more. That's just our answer. Okay, and this video is 23 minutes, so we will come back to this in a minute. Go take a break.